exchange. We call it the FTSE. And the FTSE, the Financial Times Stock Exchange, is a measure, it measures the price performance of a group of stocks. And by doing that, it allows us a better insight into how that stock is doing and how it is trading on the market. So it means something different in finance, but we're talking about the meaning of it in mathematics, indices. Now, most of you have heard about indices when we talk about big maths, and you know one of my favorite topics in maths is big maths, okay? And BIDMAS is an acronym for B stands for brackets, I stands for indices that we're looking at today, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. And when we're using big maths, it's about the order in which we operate a calculation. It's about the order in which we solve a calculation that has got more than one operation. For example, 6 plus 4 times 2. You've got an addition and you've got a multiplication. So we would need to use big maths to answer and solve that question. And big maths is worldwide. So wherever you go, wherever you're learning, whatever country you've come from, then big maths does not change. So that's where you've heard the word big maths. But let's explore, let's take a big deep dive into what indices really are and what they mean, okay? Right, so I've mentioned three, I mentioned 2 with the little 3 above it, which so the 3 is the index and the 2 is the base number, okay? That 2 is what we call the base number, and this is really important. So 2, a big number 2 with a little 3 above the 2 just to the right, that little 3 is the index number. Indices is the plural of index. Why do we have indices? Well, indices are used to write numbers that have been multiplied by themselves in a much more concise, shorter, convenient way. That's all. That's the reason why we use indices. It makes it easier for us to manipulate number and to read number and to understand number. That is why we use indices. Indices can be called power to the power of, they can be called an exponent, or sometimes you might hear someone say 2 raised to the power of 3. They all mean exactly the same thing. Most of you have heard of 2, and you've heard of squared, so 2 squared, 2 cubed, and once you go past that 3 digit, you say 2 to the power of 4, 2 to the power of 5, 2 raised to the power of 6. They all mean exactly the same thing. So indices mean something different in mathematics and in the world of finance. And in the world of finance, that's when you start to get really excited about maths and number, because you're dealing with money and you are trading. And the Financial Times Stock Exchange is, I believe, one of the world's biggest markets used for trading. You've got the Bourse, which is the equivalent in Paris. And then you've got the other one, the Nasdaq. I can't remember them all, but you've got the stock exchanges, the buildings all around the world. So it's really exciting. Back to tonight. So indices. So let's say, for example, you've written the number 4, a big number 4, and then to the right of that number 4, you're going to write a small number 3. That means 4 cubed, 4 raised to the power of 3. That digit 4 is what we call the base number. And the 3 digit that is above the 4 is the index number. So that is asking me to do 4 times 4 times 4. Now, when I multiply 4 by itself, I get 16. I've got to multiply that 16 again by another 4, and that will give me the answer of 64. So I'm able to write 64 in a much more shorter, convenient, concise way by just putting 4 with a little 3 above it. So that's how we understand and that's how we interpret indices. In mathematics, you've got the rules and you've got the laws of indices. And on tonight's math show, I'm going to be explaining, opening up, describing, and presenting to you the laws and the rules of indices. Once again, you will need paper, you'll need a pencil or a pen, because when I'm teaching on the radio, you're listening, it's audio. So by making notes on your piece of paper, you are reinforcing that understanding. If I was teaching with a whiteboard, it would look different because I'll be writing and you might be copying. But on the radio, it allows me to be very, very creative with the way that I teach. And this is what is exciting about teaching maths on the radio. And the math show is the only math show that is around in the country and beyond where I'm teaching maths every week to you, mum, dad, auntie, uncle, primary, secondary, college, university. I'm teaching maths. And that's what makes it so exciting. So we know about what indices mean. We know what they look like. We know the purpose of indices. And tonight's show, I'm going to be going into more deeper. I'm taking a deep dive into what indices are. So it's the math show with me, Mr. Numbervator, and the math show is every Wednesday between the hour of 5:30 and 6:30, and 1 hour is equivalent to 60 minutes, and 60 minutes is equivalent to 3,600 seconds. People always say to me, why do I drop all these bits of information in? It's because it's number. It's because it makes math so much more exciting. How many times do you say to yourself, I'm going to take 3,600 seconds to do a particular job? You might say it's going to take me an hour, but how many times do you say it's going to take me 3,600 seconds? Why don't you try it next time with somebody and see their reaction? Because it's quite interesting. Okay, so we know what indices are. So if, for example, I've got a question and the question is 6 plus 4 times 3. I need to use BIDMAS because, as I said earlier, I've got more than one operation. I've got multiplication and I've got division. So there's a particular order, a particular sequence that I need to use that is worldwide to answer the question. So some people would say 6 plus 4 is 10, multiplied by 3 is 30. And by talking, that is the correct answer. But in mathematics, because you've got addition and multiplication, we have to follow BIDMAS. That means brackets, indices, division, multiplication, addition, or subtraction. Now, in that short calculation, I've got addition and I've got multiplication. So I need to complete the multiplication part of that question first because M comes before A. So it's the order. So I would need to do 4 times 3 is 12, and then 6 plus 12, the answer is 18. Now, 18 is it's a different number to 30. So can you see the importance of being able to use BIDMAS correctly? If I've got in my question 6 plus 4 times 3 squared, that's interesting. 3 squared. So 3 becomes the base number. And that little 2 above the 3 is the index number. Because of BIDMAS, I would need to work out 3 squared first. Because I, in BIDMAS, comes before M in multiplication. So 3 squared is 9. I would then do 4 multiplied by 9, which is 36. I would then add 6 onto 36, and that would give me 42. So what I'm sharing with you is how to use indices in BIDMAS. But remember, the title of the show is the rules and laws of indices. And this covers a big area. And you need to be confident and knowledgeable about the rules and the laws of indices, especially as you move into year 8, year 9, year 10, and then obviously definitely in year 11 for the famous GCSE exam. I'm going to start with multiplying indices because there's a particular rule for multiplying indices. I've got a question that I've written down, and my question is 2 to the power of 5. So that's the big 2 with a little 5 above it, multiplied by 2 to the power of 3, which is the same as 2 cubed. So my question is 2 to the power of 5 multiplied by 2 cubed. Now 2 is my base number. And because 2 is the same base number, my answer must have that 2 in it. So 2 will be the base number in my answer. So 2 to the power of 5 multiplied by 2 cubed is going to equal 2 to the power of something. When we are multiplying with indices, we add the index numbers together. So 2 to the power of 5 means 2 times 2 times 2 times 2 times 2 multiplied by 2 cubed, which means 2 times 2 times 2. Now, I mentioned 5 lots of 2s when I said 2 to the power of 5, and I mentioned 3 lots of 2s when I mentioned 2 cubed. So how many 2s have I got altogether? I've got 8. So the answer is 2 to the power of 8, because I've mentioned 8 lots of 2s. Now, the easy way to remember that is when you're multiplying with indices, you add the index numbers together. So 5 plus 3 equals 8. But I need to explain to you where that 8 number comes from. I can't just say the answer is 8, because you need to understand where the 8 comes from and the significance of that 8 digit. So when we're multiplying with indices, we add the index numbers together. So once again, 2 to the power of 5 multiplied by 2 cubed, the answer is 2 to the power of 8. We add the index numbers, the 5 and the 3 together, and that gives us 8. If you want to expand your understanding, 2 to the power of 5 is 2 times 2 times 2 times 2 times 2 multiplied by 2 cubed, which is 2 times 2 times 2. That I've got 8 lots of 2s altogether. Now, 2 to the power of 5, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay? So 2 to the power of 5 is 32. 2 cubed is 2 times 2, which is 4, 4 times 2, which is 8. Now, if I do 32 multiplied by 8, if I do 32 multiplied by 8, I get an answer of 256. Now, 2 to the power of 8 is equivalent to 256. Remember when I said the purpose of indices? I'm going to read out my definition again. The purpose of indices are used to write numbers that have been multiplied by themselves in a much more concise, shorter, convenient way. 2 to the power of 8 is the same as 256. Why is it 256? Let me explain. I've got 8 2s, so I'm holding up 8 fingers to the live broadcast. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, and times by 2 is 256. So that's where the answer comes from. Now, I have just given you the value of 2 to the power of 8. 2 to the power of 5 multiplied by 2 cubed is simplified to 2 to the power of 8. So can you see the difference between simplify and give the value of? And that is what you need to remember in maths, especially as you move from year 7 into year 8, into year 9, 10, and 11. But I've had some very able year 6s who are able to understand and manipulate multiplying indices. Dividing indices, which is really exciting as well. When we are dividing with indices, and remember, we've got the same base number, and I'm going to keep the same base number of 2. So I've got 2 to the power of 5 divided by 2 cubed. So 2 to the power of 5, and this time we are dividing 2 cubed, which is 2 times 2 times 2. Right, what do we do? Well, this question, for me, and you know that I love maths and number, is also quite exciting because we know that 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, and 2 cubed is 2 times 2 times 2. And so all we need to do is, when we are dividing with indices, we subtract the smaller index number from the bigger, or the bigger subtract the smaller. That's what I was going to say at the beginning. But I like to give different perspectives on the question. So 2 to the power of 5 divided by 2 cubed is 2 to the power of 2. How did I get that answer? But this is where maths becomes so exciting. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. And we're going to divide that by 2 cubed, which is 2 times 2 times 2. So I've literally drawn, I'm going to show it to the screen. I've literally drawn a division calculation. So I've got 5 2's above the line, and I've got 3 2's underneath the line. And all I'm going to do is cancel the 2's above with the 2's underneath. So I'm going to cancel 1 2 above and 1 2 underneath. I'm going to cancel another 2 above and another 2 underneath. I'm going to cancel another 2 above and the third 2 underneath. I've got lots of 2's left over. And what is 2 squared? It means 2 times 2. 2 lots of 2's. So the value of 2 to the power of 5 divided by 2 cubed is 2 squared, which is 4. So 4 is the value. 2 to the power of 5 divided by 2 cubed, simplified, is 2 squared. 2 to the power of 2. And this is what makes maths so exciting. Can you see how we've moved up? We've moved away from big maths, and now we're going into the using and the application and the knowledge of the laws and the rules of indices. I've explained what indices are. I've described what indices are. I've painted a visual picture of what indices are. Now you are using indices. And these questions that we're going to do today, they come up in GCSE. And you won't even realize, the way I'm going to be teaching the next level, you won't even realize what you're doing. You're going to be so excited and so engrossed in your learning that it's just going to be fun. Right, my next little heading, we call it a subheading, is raising a power to a power. Raising a power to a power. What does that mean? Okay, my first question is this. I've got the big number 2, which is my base number, and I've got a small 4 above it. So I've got 2 to the power of 4. And I've put 2 to the power of 4 in brackets. So 2 to the power of 4 is in brackets. And outside of the bracket, I've got a 3 digit at the top. So it reads 2 to the power of 4 cubed. 2 to the power of 4 cubed. What does that mean? Well, we know that 2 to the power of 4 means 2 times 2 times 2 times 2. Now, because 2 to the power of 4 is inside the bracket and outside of the bracket to the top right, I've got a 3. That means we need 3 lots of 2 times 2 times 2 times 2 because we're cubing. So I've got 2 times 2 times 2 times 2, that's 1. 2 times 2 times 2 times 2, that's 2. And 2 times 2 times 2 times 2, that's 3. I've got 3 lots of 4 sets of 2s. How many 2s is that altogether? It's 12. So when we are working out the value, when we are simplifying, raising a power to a power, all you simply do is the index number that's on the inside of the bracket, you multiply by the index number on the outside of the bracket. And 4 times 3 is 12. But I explained before I showed you what to do, where the 12 comes from. Now, if I wanted to work out the value of 2 to the power of 12, I would need to do 2 times 2 times 2, 12 times. But that's your job. That's what you can work out. And that's what you can maybe send me as the answer. What is 2 raised to the power of 12? What is 2 to the power of 12? Okay? And you know what it means? It means 2 times 2 times 2, 12 times. So it's going to be quite a big number, but this is what makes maths exciting. Yeah? This is what makes maths really exciting. And the fact that, you know, it's making maths come alive. Yeah? Okay, right. So let's move on. So we looked at multiplying indices, dividing indices, and raising a power to a power. The next area that I want to look at is fractional indices. Now, when I've mentioned fractional indices to some students before, they've looked at me and they thought, oh my gosh, I can't understand it. I don't know what to do. But do you know what? Fractional indices, I think, is even easier than multiplying, dividing indices, or raising a power to a power. That's what I think. Okay? There's one thing that I'm going to tell you and teach you about fractional indices. You simply need to be able to draw the square root symbol. That is it. Once you know how to draw the square root symbol, fractional indices become so easy. The square root symbol, I'm going to show you. See, this is going to be interesting. I'm going to show you how to draw the square root symbol live on the radio. Because people are saying, how can you teach someone to draw the square root symbol on the radio? Listen carefully. You're gonna draw a letter V upside down. So you're gonna draw the letter V upside down. Okay? So you've got the letter V upside down. Now, to the right of that letter V that you've written upside down, you're gonna draw a small vertical line and then a longer horizontal line. That is the square root symbol. It's easy. Let me say it again. Draw a small letter V upside down. You know what letter V looks like. Then you're going to go to the right, the bottom right of that letter V. You're going to draw a vertical line going up, a small vertical line going up, let's say 1 centimeter. And then you're going to draw a nice long horizontal line, let's say 4 centimeters. That is what the square root symbol looks like. So when people were saying to me, how can you teach someone to draw the square root symbol on the radio? I always say, listen, where there's a will, there's a way. That means if you want to do something, you'll find a way of doing it. I wanted to teach how to draw the square root symbol on the radio, so I found a way of delivering, presenting, engaging, showing, getting you to visually picture the square root symbol. And for fractional indices, you need to know how to draw the square root symbol. Okay? It's as simple as that, listeners. Okay? So we're going to do, after the short break, we're going to come back and we're going to be looking at fractional indices, and we're going to be solving questions that involve fractional indices. And I know some of you are thinking, oh my gosh, I don't know what to do. As I've just said, it's easier than multiplying, dividing, and raising a power to a power. So a quick ad break. You can get a glass of water. Don't go too far. And I'm going to see you again on the other side in about a minute and a half, 2 minutes max. See you shortly.
You're listening to Talk Community Radio. Get the latest issue of Mr. Numbervator's Nice Comic Book series today. You are now tuned in to the Mr. Numbervator show every Wednesday, 5:30 to 6:30 p.m. on Talk Community Radio station. Let's get mathematical.
Hello, welcome back to part 2 of the Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station. And as we always say, Chalk Hill Community Radio Station is about keeping the community connected. That means teaching is part of that, keeping that community connected. It's about raising achievement, attainment, raising excitement, raising engagement. That is what makes a community. And that's what makes a community function and grow as well. So the Math Show, really, really important. Every Wednesday between the hour of 5:30 and 6:30. And I'm going to say again, 1 hour is equivalent to 60 minutes, and 60 minutes is equivalent to 3,600 seconds. Some useful and important information I've just given you. Okay, before the break, we looked at indices, what indices are, what indices, index numbers mean in the financial world and the stock exchange, but it's the Math Show. However, finance is part of maths, but we were looking at mathematics in the classroom. We're looking at multiplying indices, dividing indices, how we use indices in big maths, raising a power to a power. And now I want to look at fractional indices, and I find fractional indices quite easy to get my head around, and I want to actually describe fractional indices to you, and I know that you're going to find it quite easy to follow me and to get your head around it as well. So fractional indices, I'm going to teach it like this. I've got a base number of 2. Now to the top right of that 2 digit, which is the base number, I've got the fraction 1/2. Can you see already where I'm coming from? Right. So I've got the base number is 2, the big number 2, and to the top right of that, I've got the small fraction 1/2. So I'm going to raise 2 to the power of a half. Right, now, that 2, I've just chosen a number, but I could have chosen any number. So because I can choose any number, I'm going to say any number is represented by the letter X. So the letter X I'm representing as any number. Any number could be 36, 144, a million, or whatever it is. Now, X raised to the power of a half is equal to, so now I'm going to explain how to use the square root symbol. Remember I said to you, you draw the upside down V, then you have a small vertical line going up, and then a horizontal line going across to the right. That little gap in between the upside down V and the vertical line, there's like a little gap that you can sit something inside. Because we're raising X to the power of a half, your denominator, which is the 2-digit, is going to sit in that little gap there in your square root symbol. Is it maths exciting? So you get your square root symbol, you've got the upside down V, then you've got a little vertical and a long horizontal to the right. So you've got like a little dip, a little gap in that little space there. Because we're raising it to the power of a half, that little 2 sits in that space there. Underneath the horizontal line, let's say you've got the number 100. So that would mean the square root of 100. That's what that would mean, the square root of 100. And we know what the answer is, it's 10. So the value of that X raised to the power of a half, X is 100, and that number 100 is written underneath the horizontal line, and the denominator, which is the small 2, goes in that little gap in the square root symbol. So guess what X raised to the power of 1/3 means? It means the cubed root. Okay, it means the cubed root. So let's just say we have got 64. So X is 64. So I'm going to write, because we've got X to the power of 1/3, that little 3 goes in that gap where the 2 was, and underneath the horizontal line, I'm going to put the number 64. That is asking me for the cubed root of 64. That is what number times by itself and times by itself again will give me the answer of 64. I have covered it earlier. I'm going to let you know that the answer is 4, because 4 times 4 is 16, and 16 times 4 is 64. So the cubed root of 64 is 4. And that is the answer for that question. X raised to the power of a quarter, that means the 4th root of a number. So the little 4 sits in that gap again in the square root symbol, and the number I could have underneath could be, I don't know, it could be 1,000, whatever number it is, something times something times something. Let's say 10,000. So the 4th root of 10,000. 10 times 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So the 4th root of 10,000 is 10. So that's what that means. X raised to the power of a quarter, X raised to the power of 1/3, and X raised to the power of a half. Or it could be any number that you'll be given or that we are given. So now that we know what to do, let's actually make use of our knowledge, our understanding, but more important, our excitement for learning. Thank you. A couple of parents are just saying that, it's helping their children. That's what the math show's about. The math show is about helping, supporting, encouraging, valuing maths, valuing you as a young person, your brain, your knowledge, you as a young individual, making you better. So when I get comments like that and then balloons flying up on my phone, it makes me want to give and to do more, because that's what the math show is all about. What can we give you? How can we make you better? A better mathematician, a more confident mathematician, a mathematician who enjoys problems and enjoys solving problems and trying to work out what answers are. Okay, so let me just give you a question and let's solve this together. I've got the number 25. 25 is my base number, and I've got my index fraction is a half. So I've got the number 25 raised to the power of a half. What does that mean? The first thing you're going to do is the square root symbol. When you're using fractional indices, the first thing you do is just draw the square root. Just draw the square root sign, the symbol. Yeah, upside down V, bottom right of the upside down V, up vertical, to the right horizontal. That's what the square root symbol looks like. So 25 raised to the power of a half. Right, so I've drawn my square root symbol. 25 goes underneath the horizontal line. And guess where the 2 goes? Yeah, it goes in that little dip, that little gap in between the upside down V and the vertical line. The little 2 goes there. So what does that mean? It means the square root of 25. This is what I meant by it's actually quite easy. It sounds difficult. Fractional indices. Oh my gosh. And a lot of people don't like fractions anyway. But all you're doing is you're lifting information and you're putting it into the square root symbol. And you already know about square roots. We've had lessons on the square root, and you're doing it now. So 25 raised to the power of a half. The value, the answer is 5. Why? Because 5 times 5 is 25. If I had 25 raised to the power of a third, that little 3, that if I had 125 raised to the power of a third, that little 3 would sit in that little dip in the square root symbol. I'd put 125 underneath the square root symbol, and that would be asking me the cubed root of 125. In other words, what number do you multiply by itself 3 times to give you 125? Well, I know the answer is 5, because 5 times 5 is 25, and 25 times 5 is 125. So understanding fractional indices, at first you're thinking, oh, it's a bit tricky, and we're looking at fractions now. I don't like fractions anyway. I've simplified it for you. I've made it much more easier to understand, to comprehend, and to use. Let's use another one. 36 raised to the power of a half. 36 raised to the power of a half. What do I do first? I draw my square root symbol. My denominator in the fraction a half is the 2, and that little 2 goes into the square root symbol, into that little dip where you've got the upside down V. 36 goes underneath the horizontal line. So that is asking me for the square root of 36. So what number, when you multiply it by itself, gives you 36? Let's explore. 10 times 10 is 100. That's just too big. 7 times 7 is 49. That's still too big. 2 times 2 is 4, and that's too small. So our answer is in between 2 squared and 7 squared. 3 squared is 9. 4 squared is 16. Oh, sorry, we're looking at 6. Yeah, we're looking at 6. So, yeah, it's the same thing. So we're trying to find a number that you multiply by itself to give you 36. So 4 times 4 is 16. And then 5 times 5 is 25. 6 times 6 is 36. So 36 raised to the power of a half, the answer is 6. Why? Because 6 times 6 is 36. Let's explore. Let's develop it a bit more. 8 raised to the power of a third. 8 raised to the power of a third. What does that mean? What do I draw? I've drawn my square root symbol, upside down V, bottom right of the upside down V, vertical line 1 centimeter, go to the right, horizontal line 4 centimeters. That's what the square root symbol looks like. Now, what goes in that little dip? The 3. What goes underneath the horizontal line? The 8. So can you see how I'm just playing about with numbers and maths, yeah? So this question is asking me, what number multiplied by itself and then multiplied by itself again gives you the answer of 8? The cubed root of 8 means a number multiplied by itself and then multiplied by itself again will give you the answer of 8. 3 times 3 is too big. And then times that again is 27. That's just too big. We've only got 8. So we know that 3. So what number do we have left? It's 2. 2 times 2 is 4. 4 times 2 is 8. So 8 raised to the power of a third, the value, the answer is 2. Why? Because 2 times 2 times 2 is 8. This is fractional indices. And yes, someone has just asked me, okay, so someone has just asked me about, can you use negative numbers? Of course you can. Of course you can. You can have negative fractional indices. And that's when it starts to get even more exciting. But that'll be for another day. I want us to consolidate our learning here. And then maybe if people want me to do it as a lesson next week, you know what to do. Drop me a message. You can drop me a message on sovereigncomics.co.uk. You can drop me a message on doctor_knows-it@hotmail.com. You can send me a message on the studio number 07535 644 850. 3 different ways of sending me a message and requesting a particular topic. 125 raised to the power of a third. Step 1, I'm going to draw my square root symbol. I've got a third. My denominator is 3. That goes in that little dip in the square root symbol. 125 goes underneath the horizontal line. So what number multiplied by itself 3 times will give me 125? We have covered it earlier, but now can you see the pace of my teaching has increased because I'm putting more demands on you. What number multiplied by itself 3 times gives you 125? 5 times 5 is 25, and 25 multiplied by 5 is 125. So as I said earlier, fractional indices, they're not that bad. I mean, I find them easier than doing multiplying, dividing, and raising a power to a power. But you might think differently. You know, we're all different, and that's what makes the world go around. Okay, right. So here's a lovely question. We're going to start to finish up soon. I wish it wasn't. Time just goes so quickly. But here's another question: 81 raised to the power of a quarter. 81 raised to the power of a quarter. What is that asking me? It's asking me what number do we multiply by itself 4 times to get 81. But let's go back to the beginning. You've drawn your square root symbol. The 4 from a quarter, the denominator 4, goes into that little dip in the square root symbol. And underneath the horizontal line, you put the number 81. So that's what 8 raised to the power of a quarter looks like visually. Now we're going to solve it. So what number multiplied by itself 4 times gets us to 81? 2 times 2 is 4, times 2 is 8, times 2 is 16. So we know it's not 2. We know it's not 2 because that's too small. We've got 81. Let's try 4 times 4 is 16, times 4 is 64, 64 times 4, 24, 256. That's too big. So what number do you think we multiply by itself to give us 81? Okay, so what I'm going to do, I'm just going to show you. So 4 times 4 times 4 times 4. I was right, 250. I always like to check, 256, yeah? So what number do we have? Well, we know 2 is too small. We know 4 is too big. It must be 3. 3 times 3 is 9. Times 3 is 27. 27 times 3 is 81. So the fourth root of 81 is 3. And this is what makes maths so exciting. Okay? You are understanding now about maths and fractional indices. We've moved on from the I in big maths, what that means. We've looked at multiplying and dividing indices, raising a power to a power. Now we're looking at fractional indices. Can you see how we have progressed in this 1 hour, 60 minutes, 3,600 seconds? How much we have progressed. Here's my final question. 32 raised to the power of 1/5. 32 raised to the power of 1/5. What do I do first of all? I'm going to draw my square root symbol. The 5, which is the denominator from the fraction 1/5, is going to sit inside that little space where the square root symbol is. Underneath the horizontal line, I'm going to write the number 32. So this is asking me to find the 5th root of 32. And that simply means, what number do we multiply by itself 5 times to give us the answer of 32? What number do we multiply by itself 5 times to give us the answer of 32? So what seemed like a challenging, tricky, you might want to use difficult question, it's not that difficult. Okay, listeners, friends, colleagues, fractional indices are really exciting, and they do come up on GCSE. They come up on the year 10 paper, school exams. They come up on the year 9. You can have negative fractional indices. And all of this makes maths so exciting. My job is to open up, not the mystery, but open up the awe and wonder of mathematics. I wonder how this works. Why does this work? I want to find out how this works. When do we use it? And this is what the math show is all about. And Sovereign Comics, this is what we're teaching through our comics. We're making maths come alive. Okay, let's get back to the question. 32 raised to the power of 1/5, which means my square root symbol, that digit 5 from my denominator in the fraction 1/5 sits in that little gap of the square root symbol. And then underneath we got the number 32, which could have been the value of x. And that is asking me what number multiplied by itself 5 times gives us 32. Let's try 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. That's just too big because we've only got 32. So we know that the value, the answer has to be less than 10. The number has to be less than 10. Why? Because when I just chose 10, 10 times 10 times 10 times 10 times 10, that gave me an answer of 100,000. And that's just way too big. We've only got 32. What I'm doing is what we call trial and improvement, by the way, in maths. We call it trial and improvement, yeah? Oh, so we know that 10's too big. Let's try 3. So that means 3 times 3 times 3 times 3. This is going to get my math skills. 3 times 3 is 9, times 3 is 27, times 3 is 81, and times 3 is 243. That is still too big. So we know that the 5th root of 32, it can't be 3, it's too big. I think some of you are shouting at your mobile if you're listening, or the radio or whatever. It has to be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the fifth root of 32 is 2. And there we have it. There we have it. Okay. Today's show was about indices, the rule and laws of indices, the rules and laws of indices. You have come across indices from year 4, able year 3, primary school, year 4, when we start to show you about BIDMAS. That's the order of operations. And I teach it at that age because once you understand what the letters stand for, it's an acronym. Once you understand what the letter stands for, it's exciting, it's fun. And I just gave you a question, 6 plus 4 times 3. 6 plus 4 is 10 times 3 is 30, but that's the wrong answer because we did not use BIDMAS. How do we know when to use BIDMAS? When we've got more than one operation. And in the question I've just given you, I had addition and multiplication. We've got to use BIDMAS. Multiplication comes before addition. M comes before A in BIDMAS. So we did 4 times 3, which is 12, and 6 plus 12, the answer is 18. That's a big difference between 18 and 30. Then we looked at multiplying indices. I expanded what indices, how to read and understand indices. We looked at multiplying indices. What do? You add the index numbers. We looked at dividing indices. What do? You subtract the index numbers. I've explained why. We looked at raising a power to a power. I explained to you that if we've got 2 to the power of 3 in brackets, and then on the outside of the bracket to the top right, you've got a 2. That means 2 cubed raised to the power of 2. And that simply means 2 cubed, which is 2 times 2 times 2. We're going to do that twice, 2 times 2 times 2. That means we're going to have 6 lots of 2s. So the answer would be 2 to the power of 6. If I've got 2 to the power of 4 in brackets raised to the power of 3, that's why it's called raising the power to a power. That means 2 times 2 times 2 times 2, 3 times. We're going to have 12 lots of 2s, and 4 times 3 is 12. 2 to the power of 12. So listen, and then we looked at fractional indices where you need to use the square root symbol. I'm going to work out 2 times 2 to the power of 12. This is going to be interesting. 2 times 2 times 2 times 2, that's 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let's get the answer to 2 to the power of 12, okay? Do I need to use the calculator? Let's see how far I can go without having to resort to the calculator. This is going to be interesting. I think Dean's going to start laughing. Right, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. 256 times 2 is 512. 512 times 2 is 1024. 1024 times 2 is 2048. And 2048 times 2 is 4096. So 2 to the power of 12 is 4,000. Dean's looking at me thinking I'm crazy. Well, I am crazy about maths. It's 4,096, just in case you were wondering, what is that final answer? Hey, listen, what a lovely show. An hour is a good amount of time for concentration purposes, and we get so much achieved in the 1 hour. Thank you very much for listening. Thank you to those people who sent me comments and queries and questions about the rules and the laws of indices. Thank you to Dean, who's always here to support me in the studio, and also to Paul, who's not in the studio, but is always listening. Thank you to you out there, parents, teachers, head teachers, government inspectors, whoever you are. I know you're listening. Thank you for the support. Have a great week. Today's show was about the rules and laws of indices. Fantastic work from everyone. I look forward to seeing you all again next Wednesday between the hour of 5:30 and 6:30. And as we now know, 1 hour is equivalent to 60 minutes, and 60 minutes is equivalent to 3,600 seconds. Thank you. See you again next week. Bye.